In this video, we are asked to prove that the left-hand side is equals to the right-hand side. The first step is to rewrite the tangent terms in terms of sine and cosine. And we know that tan of x is equals to sine x over cos x. And we also know that 1 over tan x is going to be cos x over sine x. This is what we know, guys, because this is, if I reciprocate this, it becomes 1 over tan, and this one becomes cos over sine, which is the second identity. So this is what I'm going to do. So I'm working with the left-hand side, obviously. So I'll say left-hand side is equals to the sine squared 2x will stay the same. In bracket, I have 1 over tan squared. So it's going to be cos squared x over sine squared x. It's 1 over tan squared, so I put the squares even there. All right. And then we have minus tan squared. Tan squared is sine squared x over cos squared x. All right, ladies and gents. And then from here, we need to find LCD, the lowest common denominator. And we can see that the lowest common denominator will be, okay, let's write it here. LCD will be sine squared x, which is this part, multiplied by cos squared x, which is that part. All right. And then we keep on saying left-hand side is equals to, if you check, ladies and gents, we need to multiply this side by let's do this, by cos squared x, so that the LCD is complete. We need to multiply this side by sine squared x, so that the LCD is complete. But what we multiply on the bottom, we must also multiply on top. So this is the case, ladies and gents. I'm multiplying by cos squared here, I must multiply by cos squared there. I'm multiplying by sine squared here, I must multiply by sine squared there. And then now we have this, ladies and gents. Outside the bracket is still sine squared 2x. In bracket I have cos squared, let's use a highlight. I have a cos squared times a cos squared. It's a cos to the 4, you agree? It's a cos to the 4x minus sine squared times sine squared. That will be sine to the 4x all over the LCD, which is sine squared x cos squared x. All right. And then this is equals to, we can agree, ladies and gents, that this part here can be written as sine, let's see, should I leave it like that for now? Yes, let's leave it like that for now. So it's sine squared 2x. In bracket, we can see that this is difference of 2 squares, right? Is difference of 2 squares. So we're going to have cos squared x plus sine squared x, and then the other bracket cos squared x minus sine squared x all over sine squared x cos squared x. This is still cos 4x, and then this is still sine to the 4x, right? The middle terms will cancel each other. So we had difference of 2 squares there. I want you to always think of trigonometry, especially identities and general solutions, as algebra, because that is what it is. Okay. Okay, ladies and gents, let's go on. We know that sine 2 theta is 2 sine theta cos theta, right? So I'm going to change sine 2 theta to 2 sine x cos x, but there's a square, so I can repeat this twice. 2 sine x cos x. I'm talking about this party is sine 2x. So sine 2x, according to the identity, is a double angle identity, is 2 sine x cos x. And I repeated it twice because it's being squared, so it means it's repeated twice. right? And then in bracket, this part here becomes 1, right? So it basically disappears, ne? It becomes 1. So this is 1. And then if you look at the second bracket, this is an identity, ne? This is cos 2 theta. Okay, so multiplied by cos 2x all over sine, the sine squared x, ne? I'm going to write it this way. I'm going to say sine x times sine x, ne? And then also the cos squared x, I'm going to write it as cos x times cos x. Okay, now ladies and gents, we can cancel some few things here. Let's see. This guy will cancel with that guy, because remember this is over 1. So the sine x will cancel with the sine x. The cos x on top cancels with the cos x at the bottom. The sine x cancels with the sine x, ne? And then ladies and gents, you can see now that we only left with 2 times 2, which is 4, and then cos 2x times 1, which is just, because we have 2 times 2 times 1, that is 4 times cos 2x. So you can see, ladies and gents, that the answer will be 4 cos 2x. And let's see what we were proving. We were indeed proving 4 cos 2x. And this is indeed equals to the right-hand side. Or if you want, you can say, therefore, left-hand side equals to the right-hand side. And that is proven, ladies and gentlemen. Thank you very much. Please don't forget to subscribe, share with family and friends.